Hello. As Ivana said, my name is Jakub. I come from Poland, and I am very excited to be here today. And if you have any questions, I think we'll have time at the end, but I probably won't be able to see any of you anyway. It's going to be fun. So if you want to follow the slides with me, they are more or less identical under this link. If not, you can always revisit that later. So we're going to talk about flawless testing. And before we go on to the actual implementation of the talk, let's look at the jingle. So when we think about testing our programs, and when we go to find a new testing library or framework, what we're most likely to see is something like this. We'll see a very simple test suite with just a few test assertions, and it will all look very beautifully. But the reality is slightly different. Sometimes we will have tests that are much more complex than that, and it turns out that the DSL of the test framework and all the syntactical additions that it gives us so that we don't have to do a lot of stuff on our own, it all gets lost in there like tears in rain, because the rest of the test that just takes over. So I think current test frameworks in Scala and in many other languages are sort of optimized for being nice to read on a smaller scale with very short tests, which you should probably have. Like, you should have small tests that are not very complex. They shouldn't have any business, any logic that should be sort of tested on its own. But then again, sometimes you have to simulate some cases, like with concurrency, and you have to prepare a lot of stuff, so your tests will become more complex. So with that in mind, I want to talk about a couple of things. First of all, about what it means to design APIs in a functional way. Then we will talk about what the traditional test frameworks look like in Scala. And then I will show you some of what I've been thinking about for the last couple of months in terms of, in the context of testing functional code in a functional way. So the first part, functional API design. This can be divided into two parts that are equally important. Basically, designing data types and designing functions, because that's all we have. So we will have algebraic data types, or generalized algebraic data types, and pure functions. And this should be all that we are going to need to design an API that's purely functional. Algebraic data types, for those of you who don't know, they are one of two things. First of all, we might have a product, so we will have one or more things. Well, we will basically have a couple of things in one type, like an identifier and a string, or a string and a list of people. In this case, that's actually a recursive type. It would probably not compile, but this is all like pseudocode, so don't take it very seriously. So products are a combination of a couple of things. But then we also have co-products, which are basically one of a couple of things. So true or false, sum of A or none. So basically, this is what we encode right now in Scala as sealed trait hierarchies. And in Dotty, we will be able to do this in just one line, like here, pretty much the same syntax. And yeah, as I mentioned, these are products and co-products. So we sort of think about all of these things in terms of products, and one of these things in terms of co-products. And co-products are also called sum types for reasons that are sort of beyond the scope of this talk. But what's important is that these two things, and just special cases like the nothing type and the unit type, this is all we need to encode pretty much everything, pretty much every data type, just using ADTs, just using products and co-products. We can encode a bit using a co-product of off and on. We can encode a byte using a product of 8 bits. And we can encode a string as a list of chars, which are bytes. in this example. And from there, we can go on to build basically any structure we want as just a product or co-product. And why are these product types and sum types? So basically, the amount of values that fit to a given type, they change according to rules of addition and multiplication. I'm not going to explain that, but it basically means that these two types are equivalent because the amount of values of those types is the same according to this calculation. And there's many more equivalences that we can find in our types. And those can actually help us simplify our APIs. For example, here you have a bunch of equivalencies that you can implement very easily. And I encourage you to take a look at code with a lot of nesting of these structures that you might have at work or at home. And just look for patterns. Maybe there's something you can simplify. And these all can be proven if you think about either an option as algebraic data types. But how do we use them in real APIs? We're going to look at one example, which is messages for a message queue. So let's imagine we have three kinds of messages. We have a text message, which carries a UTF-8 string as payload. We have an object message, which carries any serializable object. I know, I don't like this, but that's the API. And we have a message called ping, which doesn't have any kind of payload, but it still is a kind of message that we need to encode in this data structure. And all of these will have the same couple of fields. So there is some common structure in them, but they will still have a different payload. Like each of these messages will have a different type of payload. So the first idea you might have, if you come from an object-oriented background, and this is something I've seen very often, is to come up with a trait, or maybe a sealed trait, that has depths for all of these common fields. And this is not exactly what I would think about as an ADT. Like, you may agree or disagree with me, but I think that's not exactly what an ADT should be. Because we have some sort of common structure, but it's sort of separated from the data structures that we have, like the text message, the object message, and the ping message. They still have to repeat their two types that are shared, the fields, the ID field and the timestamp field. And it only works because the encoding of case classes works because these fields sort of override the method in the trait. So a more algebraic data type approach might look like this. We will not have abstract methods that will be implemented by these case classes that implement the message trait. We will have a method that does pattern matching on these types, on this type, and extracts the fields that are common using a simple pattern match. There's some repetitivity in here, and the more fields you have in common, the more this is going to look bad. But it still works, and that's actually more like an ADT. But that's not the right way to design it. We can think about our data type in a different way. We can start with the fields that we have in common. We can create a new case class, a new product type. Start with the fields that we have in common, and then add a new field for the thing that changes, called the payload. And then the payload will be a closed sum, a sealed trait hierarchy of three types with payloads, with a string, a serializable object, and, well, there's no payload in the third one. So it's just a case object. And then we can implement friendly constructors for these known types of messages, like the text message, the object message, the ping message, just on the message companion object. And this is, again, a lot of typing. Like, compared to the previous examples, there was lots of typing somewhere else. But I still think this is more like it should be done. And if you need to work with a structure that's like a payload, like a message, and you want to distinguish it by type, it sort of makes that side of your code clear. But now we have a problem. what if we want to know the exact type of the payload in a message? We want to write, previously we were able to write a function like this, a function that only works with text messages, just by saying the argument is a text message. But now we cannot do this, because we just have a single message type. So how do we do this? Do we throw an exception if it's not a text message? We shouldn't do that, right? So here's a slightly modified structure that we had previously, except now our payload is parameterized with a type parameter. And we have three kinds of payloads, a payload of string, a payload of serializable, and a payload of unit. And our messages are also parameterized with that, so that we keep the information about what payload we have in the type of the message. And that's called in general, that's called a generalized ADT, or GADIT. In this case, that's the payload type. The message is now just well, I wouldn't really call it a generalized algebraic data type, because what makes payload a GADT is that each case has a different type, and in the case of message, there's just like one case, and it's further sort of parameterized in the payload itself. Anyway, now, given this new type parameter in message, we can easily write a function that only accepts messages of a certain payload type, like string. And now we are happy again. We can actually work with this. So we have plenty of approaches for defining data structures in this way, like using a very, very simple ADT that doesn't have any sort of typed payload, like in the first example. Then we can parameterize that payload with a type parameter using a GADT. Or we could allow any kind of payload, which is also possible. We just parameterize the message and we don't have a payload type at all. Or we could have a payload type like in a payload type that's an ADT without the type parameter, but we parameterize the message with an upper bound of that payload, so that we keep the exact type of the payload in the message. And all of these approaches, there are of course many other possibilities, but these are just like the four most basic ones. They all have their own abilities. Like you can do different things with these. For example, with an ADT, we constrain the payload type to just payload. In a generalized ADT, we constrain it to a payload. We can constrain the payload of the message to something that extends payload of P. In a generic case, like the third one, we can have any kind of payload. And if we add an upper bound, then it's still bounded to payload. But there are differences in, well, the first and last one are the same in this case, but the generalized ADT sort of gives us this additional information on what the type of the payload is, just like the right one. And we can abstract over the payload, but not in the first case, not in the case of just an ADT. We can do it in all the other cases. And if you want to use very, very precise types, like singleton types of some value, we cannot do this with ADTs because we have no abstraction at all, so it doesn't really apply. And in generalized ADTs, well, it only works if the children of the payload type support that. So if our payloads extend like payload of string, then that's not precise enough, so we cannot really do that. But in the other cases, we just need a specialized like, type of our payload. We put that in the message, and it sort of works out of the box. So depending on what you're looking for, what possibilities you want to give to your users, the users of your API, you will need to choose one of these or maybe a slightly different approach. But you still need to keep in mind what possibilities you give to the user and what you can do with your data type. Because the more you constrain it, the more you as a library author can do with this type, but you take away some power from the users of your API. So that was data types. Now we'll talk about functions for a while. So on this slide, there's 0 functions on this slide, because the thing that we have, this method pay, is not a pure function. And I can easily prove that by writing a program using this function, using this method to pay once from the card, and then we will use the same card and print its remaining credit. So now after the payment, it's reduced to 200. But if I make a simple refactoring and I inline the card variable, I will now have 2 different cards, and the credit will not be subtracted from the first one. Well, it will be subtracted, but I will no longer have access to that, and I will just have a fresh card every time I use it. So that's not good, and that's the easiest way to break referential transparency, which is very important for pure functions. So let's revisit our example, and let's actually make our pay method a pure function. It will now take the amount of money that we want to pay, the card, just like before, but it will not return unit, it will return a new card. So we will return a modified card that has less credit, and now we can pay with it, with the old card, which will give us a new card. And then we can print the credit of the new card, and we also still have access to the credit of the old card, which might be useful, might not be. But this gives us this refactoring ability that we can now inline the pay function or the new card val, and everything will still work in the same way. And if you want to change this sort of operations, you may have seen something similar on talk by Sebastian yesterday. It didn't look really nice, because you would have 7 cards after 7 different operations. And what do you do? It's very easy to make a mistake and use the wrong card in the wrong place. But there are things that allow us to sort of hide that behind the monad, of course, which is actually really nice to use if you know how to do it. And if you want to learn how to do it, I recommend you get familiar with the state monad, which is beyond the scope of this talk. So as I said, I can now inline the card variable, which is actually a constant, and the program still works in the same way. So great success. But then you might be thinking, hold on, wait. These functions only work because this is pure, this is an example. This isn't the real world, and we don't interact with the real world. But let me show you functions, pure functions, in the real world. We can use the same principle, just passing things around and returning things, to reason about pure functions even in the presence of real-world problems. So in this case, let's have 2 functions, because now we can no longer sort of take money from a card, because we will have some sort of database. So we need access to that database, and that's how we get the amount of balance left on our card. And that's also how we interact, how we make the payments. We update the values in the database. So now we'll have a new program in which we create a database. Like in this case, it's an in-memory database, but it could as well be a database connection and a connection pool. And then we use that. We create a card ID, and we use this card ID to pay using that card twice. And then I will get the credit remaining on that card and print it. And it turns out that this is a purely this is a pure function in the presence of the real world. Now I can also apply an extraction or inlining, and the program will work in the same way. Because a call to the pay function doesn't actually make any changes in the real world. It's only a description of the world, which of the change to the world, which I can then use as many times as I want, and the action will be executed as many times as I want. So that's it about pure functions and functional API design. Let's talk about traditional testing frameworks. So the traditional testing framework, what it allows you to do is to make an assertion. You pass in a Boolean or some sort of predicate, and the test framework verifies for you if that it's true. If it's not, it will throw an exception, usually. Like most test frameworks will do that. They will throw an exception at this point, and that's it for your test. Your test stops at this point, it's failed, and then the framework goes on to the next test. Which is not so nice. And that's just one case of well, what if you actually wanted to see what the second assertion was? Like, does it succeed or not? And even in the scala test, where you have matches that are more complex than just assert, you can do like lists should be empty or lists should have size 3. It will still throw an exception if the assertion doesn't pass. So the rule is the same. And that's an exception, a case with throwing exceptions, which is normally not very nice in a functional environment. But what test frameworks also do, at least most of them, they will have side effects. So they will break the referential transparency rule, and now your test functions, even if they are functions, are no longer functions. They're just method calls with side effects. So let's imagine we have this like test suite with 2 tests, and let's imagine one of them is getting longer and longer. We want to extract it to a new thing. We want to move it somewhere, but still run it here. So we create a val before, and because of how test frameworks work, because the test function is a side effect, we cannot really do this because it depends on the fact that we are in the tests function call. That's just how tests get registered. And this is what I call functional programming. So you base your functions on thunks. You have like if you write in this style, you will most likely have this lazy this by name parameter everywhere. And this is also what happens when you work with futures. Like when you want to write a retry function for a future, this is what you're going to get. You're going to have functional programming, which doesn't compose, doesn't scale, and it's really annoying if you don't know what's going on. So we would like to avoid that. But here's another problem with traditional testing frameworks. Well, at least I think it's a problem, because if you create a test suite as a class or object, depending on the framework, it will just get picked up by the test runner, and then it just runs. That's okay, but that becomes a problem in the presence of concurrency, and if you have some resources, like if you have tests with a database, then you are probably going to have some interleaved tests unless you disable concurrency globally. And I think that's unfortunate, because sometimes you want to have some tests running concurrently and some tests running separately, and that shouldn't be a matter of sort of a global restriction in your build file or in your test config file. It should be possible to run tests in sequence with each other or in parallel to each other using a composable fashion. This doesn't compose that well. And there's also one more thing that I don't like. Like if you have any sort of resources in your tests, you cannot pass these resources around to tests to reuse them. And you need to sort of have these setup functions, which are like lifecycle hooks, but for tests. You will have these setup functions and these teardown functions, and that's where you have to do nasty side effects. you have to use try finally to ensure that things get closed, like all of the things get closed, even the first one, like throws an exception or something. So it's a sort of ad hoc solution for a bigger problem, a problem that you cannot, for example, create a single resource and use it in all your tests. Like, why would you need more than one database connection pool for 10 test suites? You could just use one. And the fact that we use test frameworks that are currently present in the Scala ecosystem sort of makes some things related to resources impossible. So that's it for traditional testing frameworks. Now here's what a functional testing library would look like. First of all, we would need a purely functional DSL, or you could write a data structure for tests. But what matters is that there are no side effects and no exceptions. Like, an assertion should be a value, a test should be a value, and the test suite could also be a value for reasons that I'm going to show later. And you could have, if you had assertions as values, you could combine them together. You could say this assertion and this assertion, or this assertion or that one. And the test library should give you the ability to do that, to have more than one assertion, so that you have more detail on which part of the test failed and how. So in this place, we make a call to the service that we are testing, and our implementation of some sort of dependency would make a side effect that we can actually a functional effect that we can later inspect and verify that the effect that happened was what we wanted. And then we can combine both the assertion of the result of our function and the assertion on the effect of our function together. And this scales to the big examples and the small examples. We can make simple assertions and still benefit from this. We would be able to see exactly what went wrong. And we would be able to see if both assertions failed or just one or none of them. And I believe we should have the power to register our test suites ourselves. We would just have a single place in the application, in the test application, where we would sort of say, okay, these tests run in sequence, but those can run in parallel. And then let's run them all sequentially, like here. We would have maybe an operator that would take a sequence of test suites and run them in a sequence or in parallel and combine like multiple results. And about resources and lifecycle management, we already have very nice tools for that, at least in the CATS effect ecosystem, but as well in Zio. We have the resource monad or the managed monad. And these are very powerful utilities that we can use to make resource safety much easier. And this can also scale to our tests, because why not? So here's a look in the future. So what I've been thinking about for the last couple of months was something like this, a functional testing library that would give you the power to do things in a functional manner, to test in a functional manner. So if you use this library or something like this, you would have some sort of DSL that would not actually make any register any tests in a global runtime or run any tests immediately. You would just build up a data structure of tests, and this would be a sort of recursive data structure if you wanted nested tests, or if you treated suites as just sequences of tests. And there's quite a lot of things we can do on data structures. Like this via operator at the end could run some sort of aspect on each of the tests that we have. like run each test until it fails to find flaky tests. Or we could have a way to catch non-fatal exceptions in our tests, because by default I would assume there are no exceptions. We could retry each test or each suite of tests and do this like on the very end of the test suite. Just say that I want to retry each test. Or I want to cache tests that have no effects. And until I recompile my whole project or my test suite, I would not have to run them again. Or maybe I would want to time out each test to some amount of time, so that no test takes longer than 5 seconds. Or maybe I want to skip tests that take long to run, like tests that have any sort of I/O, or tests that have any sort of resources, like external resources. Or maybe I want to skip all tests because I'm working in a company that doesn't like tests. So there's a lot of work to be done. Like, I've been thinking about this for maybe the last 6 months, more before the conferences and less after the conferences. But still, it's a very exciting design space, and I'm sort of exploring what's possible. So I want to experiment more with the API in the nearest future. Like, I've already made so many changes recently that all the snippets that you've seen are just like hand wavy, and this is no longer what it looks like. I'm looking for the right abstractions for the way we combine things. Like, if I want to combine 2 tests, how do I make it explicit that they will be run in parallel? How do I make it explicit they run in a sequence? Because I do not want to invent like new operators, new syntax. It would be nice to use something that already exists in a library full of abstractions like cats. There's also the problem of constraints and liberties. So basically, how much do I limit the API to still allow users to do everything they want, but be able to reason about what they do in a sort of closed space? And basically see what is possible, like how much difficulty in writing tests are people willing to take, while to benefit from the functional approach. Like, do people even like to do something like automatic test registration, or do they hate it? And how much are they going to like having to do things on their own? So I'm looking forward to your feedback and other ridiculous ideas that might be useful in this context. And here's a new part of this talk. So this may all sound quite familiar to people who've seen Zio test. So a month or 2 ago, John merged Zio test into Zio, which actually has pretty similar ideas, some of them. And as you can see, it's been a concurrent process, sort of. So we didn't know about each other's work, but sort of led to the same outcomes, in a sense. So this is like a Zio test and a flawless test. It all looks pretty similar, so that sort of makes me think that I'm going in the right direction. So the future is now. You can already use Zio test, even with Cat's effect, like if you're not a fan of Zio, which is cool. And before anyone asks, here's a short comparison. That's just part of it. But basically, both approaches are purely functional. We just have tests as a data structure that can be traversed. Like each test can be modified from the outside using some sort of operator called an aspect in Zio. And that's the same in Flawless. But then there are some fundamental differences in one and the other. So Zio test is not very minimal. Like, it includes a lot of things for testing. They have property testing utilities, which I don't want to think about yet, because there's just so much to do in the scope of just normal testing. And yeah, they have arbitrary nesting of tests, which is not a thing in Flawless yet. And it's available now, but for Flawless it's going to take quite a bit of time still. So it's a work in progress, but since we have time, I'm going to give you a short demo of how it works. Let me just this is going to be interesting. Let me just switch the display. Okay, so you should be able to see my screen with some code. Yes. So because there's no automatic test registration and there's zero support for SPT's test interface, at least yet, apparently I don't have that much time. It's okay, so it's -5 or 5? Okay, cool. So I still have some time, good. So here's just how it works. You just run an application that takes care of running your tests. So it's not like test, it's run. And the application looks something like this. You just collect all your test suites, and you decide how you are going to interpret them, how to run them to a single I/O. And in this case, I just run all my test suites in parallel. And this is the old syntax. It will change because it's not very ergonomic right now. But just to give you an idea, let's disable that for now. And let's write a new test suite. So this is how you would approach it. You would create an I/O app on your own, like a single I/O app for all your tests in your module. And if I had a single suite, it might look like this. We could import the syntax. And then, yeah, we could define our test, like use a single test. Hello, scala-italy. And it's actually going to be a pure test without any effects. So I'm just going to verify that there's enough people in the audience. Okay, and let's run that. So you can see that I got some result, but okay, that's just one assertion and just one test. So let's make another assertions. Let's verify that the attendees are happy. Sorry, wrong operator. And yes, we got 2 assertions, but what if you were not happy? So now I would get information that this assertion didn't succeed, but there's one that succeeded. So in the succeeded line, there's still one assertion. We should see like all the details, and maybe the assertions would be named in the future, but that's just how it works right now. Okay, so that's the demo. Again, I'm not very attached to the current syntax of this should be thing. This is probably going to disappear soon. Zeotest had a very good idea to not have any implicits for syntax and not have any macros. And here I use macros to get the current line and file, which will be useful, but probably not necessary in our cases. And okay, that's going to be it for the demo. So if you're interested, let me know. Talk to me afterwards. Send me a tweet and read my blog. You can see the slides later under this link, and the code is also going to be available. I'm going to tweet the site link anyway, so that's all I have. Thank you very much for your attention, and I hope you liked it. Okay, so I'm not sure if we have time for questions.
Come in with the microphone.
Okay. Is there any question here? Does anyone have a question? No questions. Okay, whoever asks a question can get the early demo. Okay.
I can ask a question if you want.
Yeah.
So in SBT we have test quick and test only commands. Is that something that could be supported by your framework? Or do you plan to do it?
Yes. So I was thinking about it, and I definitely want to support tests only. So if I make the decision to make pure tests, still suspend the evaluation of your code. Like it's not suspended right now. If you have a pure test with just pure logic, it's going to run pretty much when you create your thing, because there are supposed to be no side effects, and I sort of assume that. But if all the tests were suspended, then that would be much more useful. And I definitely want to do that, but that would be like baked into the function that sort of takes your test structure and converts it to an I/O. So I don't know if you saw it, but in here, that would be the, where's my cursor? Yeah, that would be the run test function. Like it would take some command line arguments, and that would define which tests are going to run. For test quick, it's actually slightly more complex. So I'm definitely looking into ways to make it as user-friendly as possible, while keeping some core constraints. But yeah, I haven't really figured it out yet. But I definitely want to do that. Thanks for the question. Oh, and it's not going to be a framework. I still want it to be a library. In the repo, it's called a no framework. So, yeah.
I thank you very much for the talk.
Thank you.
Stand up. So I saw that you don't have any kind of discovery of test suite. You just have to enumerate them in your kind of main app. Is a thing you're going to consider to have discovery, or is just a decision that you haven't done yet, or you decide to not support discovery?
Yeah, so for now I decided to not go with it just because it's simpler to experiment with this that way. And it also gives you all the control, but I think if some people just didn't want the control and wanted some defaults, then automatic discovery should be useful. So I'm looking to investigate whether that could be done with a macro or something, because I really don't like looking on the class path. It sort of smells of reflection and all the evil stuff. And I've already had tests that didn't run because I had an object instead of a class, which is really annoying. So I want to avoid that. If your test doesn't get registered, it just doesn't run. And if you register it the wrong way, it won't compile. So yeah, there's a balance that we need to sort of find, but I'm definitely not closing the door. I will consider that as well. Thank you. Okay, any more questions? No. Okay. So thank you. One more. Yeah. One last time.
And about the composition of services using during the test, this is a main topic. For example, Zio already have the environment, so you need to provide the dependency of the services. But generally working, you need to test integration test with Kafka or other systems. So it's very important. And generally, when you are working with the I/O, you need to pay attention if the services are already in scope or for apply your
yeah, so I think if you are going to interact with external systems, you will just build up a resource of the connections or the clients. And if you want to reuse that between tests, it's great, between suites, because you could just create a single resource and pass that, the value of that to every test suite. But you could also, there's nothing to stop you from creating a resource for each suite or each test. You could do that as part of your the initialization of your test suite class. Basically, it all follows the rules of composition of normal I/O. and keeps refresh transparency. So if you want to have a resource shared between tests, you will pass it through the constructor. And that's just also how you pass like services that have no effects. If you wanted to do that once per app, then sure, just pass it through the constructor. If you want to do it in every suite, you would just call the constructors inside it. That's basically it, unless I'm missing the point of the question. Okay, thank you.